Hello everyone. We are going to be solving 2210 count hills and valleys hidden array. This was a this was a daily lead code problem given on 27th July, that is Sunday. Before starting this problem, we shall have a small motivational quote. Overthinking is the biggest waste of human energy. Trust yourself, make a decision, and gain more experience. There is no such thing as perfect. You cannot think your way into perfection. Just take action. Real world feedback like failures teaches more hypothetical perfection. The best architecture emerges from actions, not theory. Let's understand this problem. This is an easy type problem. You are given an zero indexed integer array nums, and index I is part of a hill in nums if the closest equal neighbor of I are smaller than nums is smaller than nums of I. Similarly, uh, an index I is part of valley in nums if the closest non-equal neighbor I are larger than nums of I. So it means nums of I is smaller than its neighbor. That's what it means. Adjacent indices I and j are part of the same hill or valley if nums of I and nums of j. Note that for an index to be part of hill or valley, it must contain a non-equal neighbor on both the left and right of the index. Return the number of hills and valleys in the nums. Okay, so we need to return the number of hills and valleys, right? So this is a pretty interesting problem. Let us go over this example one. So 2411. This doesn't constitute as an hill because there is no sufficient neighbor, because this is the starting index, and we can start off with 4, which is an hill, as to say, with this explanation where the closest neighbor 2 is less than 4 and 1 is less than 4. So we have one hill, and once we come to this index, which is 2, uh, at index 2 the closest non-equal neighbors of 1 are 4 and 6. Non-equal neighbors are 6 and 4. So since 1 is less than 4, uh, and 1 is less than 6, index 2 is a valley, right? So we also have a valley, and here this one, which is an index 3, 0 1 2 3, so 4, the closest non-equal neighbors for 4 uh, are 4 and 6 again, right? So let's read what this explanation has to say. So at index 3, so 0 1 2 3 4 5, so there are 5 index. So at index 3, the closest non-equal neighbors are 1 and 4. So 1 and 4 of 1 are 4 and 6, right? For 3 and also at index 2. So since 1 is less than 4 and 1 is less than 6, index 3 is a valley. So both index 2 and index 3 are valley, and at index 4 we have 6, where the non-equal neighbors are 1 and 5. So the closest non-equal neighbors are 1 and 5. Since 6 is greater than 1 and 6 is greater than 5, index 4, this is an hill, right? So we have two hills. And index 5, which is of the value 5, the non-equal neighbors, there is no value and values. So there is no neighboring indexes. So 5 is neither a hill nor a valley, just like the index 0. So out of these set of three, these two are equal. So we have two hills and one valley. So that's the whole solution that we are given with. And in this example, index 0, there is no neighbors. This cannot be constituted. So index 0, which is 6 on the non-equal neighbor of 6 on the left, no, there is no non-equal neighbor on the left, so we are ignoring this index. Coming to 1, we have index 1, neither a hill nor a valley, since both the values 0 and 1 are equal. While we come to 5, this is again not neither a valley nor a 0, 1, 2, 5. So at index 2, the closest non-equal neighbors of 5 are 6 and 4. Since 5 is less than 6 and 5 is greater than 4, it is neither a hill nor a valley. Similarly, for the index uh, at index 3, the closest non-equal neighbors are 5 and 6, and of 6 and 4. 6 and 4, since 5 is less than 6 and 5 is greater than 4, it is neither a hill nor a valley. At index 4, the closest non-equal neighbors are 5 and 1, so it is also neither a hill nor a valley, right? So, and there are no hills and no valleys, so the output is 0. That's the one that we see. So we need to come up with few things or few patterns that we need to understand if we need to call a specific index as a hill or a valley, right? So the observations that we are having to see with the examples and the problem is, if it's a hill, then the left and so left and so if it's a hill, uh, the specific index should be greater than left and also right. So both, it should be greater than both the left and right index. If it's a valley, then it should be uh, nearest left, nearest right, non-equal left and non-equal right with this index. And valley is just the opposite, where there are non-equal neighbors greater than the value of an index. So this is the definition of an hill or a valley. And the ones that are at the starting and the ending index, we have already seen they do not come into picture, as they would not be having neither the left or the at the ending index, it wouldn't have the right value, so it would neither come into picture of hill or a valley, right? So that being said, we can come up with few logics where, let's say, we can keep track of a we can uh, we can run a for loop through the nums array, and we can check if nums of I is not equal to nums of I plus 1. If that's the case, then we check nums of I is greater than nums of left, and nums of I is also greater than I plus 1, that is the right side value, or if it is less, or nums of I is less than left and less than right, then it's a valley. Uh, we can just keep a count pointer, just saying that either hill or a valley as a return value, right? So, and uh, we also would be needing a left pointer, a left variable, which would so I would go to the lead code editor and start coding it up. Maybe we shall understand what I have written in the code, right? So, so with not much explanation, I'm directly into the lead code editor trying to solve this. So this checks if the two values uh, on the right and the current value is not equal, then we come to the typical check of if the current value is greater than the one on the left and also the right. That is, okay. So just to understand what we have here, so we are basically checking if the value at the current and the next index are not equal, and also if there are values of a specific index such that it is greater than the left and also the right, then it's called a hill and we are simply increasing the count. If it's less than, then we know that it's a valley and we are still increasing the count, and also the left pointer just to be tracked at the specific I value, and this I value starts at 1. We already know that the first index and also the last index won't be taken into consideration, as they won't be having the neighbors at the left at the start, and also the end of the array wouldn't have a right neighbor, right? So if you see, we are having to initialize this left variable. This is used to keep track of the last unequal number in the left side. uh, as we iterate through the for loop, we are having to check the two non-equal neighbors. So that's where this left, we which we are having to define, would come in handy to keep track of the left variable which is non-equal, right? And finally, we are returning the count after this core logic, which checks if they are of a hill or a valley, right? And let's try submitting the solution. Let's see if this works. I see this logical error where we are increasing the left, or we are changing the left pointer to the current index only if there are two consecutive values that are not equal, right? So that's when we are changing it. I hope you understood this solution, and I would like to hear your thoughts around how this left pointer is working. Even though I have not provided sufficient explanation here, food for thought, and also just to keep the comment section going with all the active viewers, right? Please, you can please write me in the comment section how this left pointer is being used here. So the time complexity of the solution would be of n, as we are iterating through the for loop n times with the nums array of length n, and also space complexity would be of n, as we do not have any dynamic uh, memory that is being used. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.